My name is Pavlo Babenko, and this is my first public talk, so I'm a little bit nervous. But today I want to talk with you about offline-first React Native applications in the real world. A little bit about me. I have over 5 years of software development experience. I started as a Ruby on Rails developer, then went to front-end frameworks like Ember.js and so on. And about 2 years ago, I switched to React Native because we wanted to translate our mobile applications into universal hybrid code. And we tried different solutions, starting with Ember.js wrapped into WebView, going through Xamarin, and so on. And we ended up with React Native. It was really drafted at that point, but we figured out that it works best for our cases. And on my day-to-day work, I'm building applications that need to communicate with the server no matter what internet connection conditions users have at the moment. So that's why offline is very important. And today I would like to talk about it in a bit detail. So let's start with something simple. Let's pretend to be the user for a moment. And as a user, sometimes I go to visit my grandma in the middle of nowhere, and if I get a new brilliant idea, I want to be able to write it down immediately and start working on it so that I won't forget about it later, and we became rich and famous, obviously. Given that I have a perfect application for node structuring, and I'm trying to open it without internet connectivity, and it says something like, "You're currently offline, sorry, please try again later," and I forget my idea, and I delete the application, and obviously I die in oblivion. So at this point, as a developer, I just close the user. And given that there's 2.2 million of apps in the iOS App Store alone, and 80% of them will never be open again, I think that's not what you want. Probably. Maybe you just like losing users. So that's why you need to think about offline support, because we're living in a world when connection isn't stable or sometimes isn't present, like here in the conference today. And as a developer, it is your task, it is your job to convince the product owners that they need to dedicate resources, like money, time, and so on, to develop something that will provide a better usability for the user while offline. What should you do if there is no connection? You can display a notification, obviously. Like here, there is a notification, red warning at the top, saying that, sorry, you're not connected to the internet. So you can plug in to PayPal, or Slack went a little bit further. They have an offline notification and a button on the top right corner that allows you to try to reload data. Maybe connection just appears and the application still doesn't know about it. And there is it's not the best image quality I expect. Okay, but here you can see the top. I think this is a top solution for every application. There is a handy icon there, text saying something like, oops, something went wrong, and a button to try again, so the user understands what's happening and why he can't or she can't find a flight from Vienna to Kyiv in this particular case. So that was easy. And what we can do as next step, we can restrict certain actions. This is example from a nodes structuring application. Oh no, it's actually a Pocket. And while they're storing your files for offline usage later, when you'll try to pull to refresh, they will show you a notice saying like, you're not connected to internet, you can't do this action. Therefore, user will still be able to navigate through the application, but with some limited functionality. Or we can pretend that nothing happened at all. This is what most iOS built-in application do. So this is a photos application. It syncs my photos to the server and backwards. And I can take a photo at any moment of time. I can view some photos that were already taken. And I doesn't care whether I'm connected or not at that particular moment, because everything will be done in background. It will sync. I can later open it on my MacBook, for example. And this is like a top-notch solution for offline, but it's expensive and hard to develop. When dealing with offline, when dealing with UI, there is like a defensive design principles. There are 3 of them. They're very simple. Each of your screen will have 3 states: an expected state, a loading state, and a blank state. As developers, we tend to start working on expected state because we have UI, we want to get our application built quickly, and we want to get the results as fast as possible. But I don't like to do it, but I will suggest to start with a blank state. So this is an application, this is blank state for application. It's called SideChart. They have 2 million of users, and this is what you will see if there is no connection and you just open the application. And the same for Facebook. They have a bit more than 2 million of users, but at least they are saying you that they can't connect, and there's a refresh button, and at this point your user knows what's happening. And there's then going loading state. This is a state when you're trying to fetch data from the server and prepare it to be shown to the user. Ideally, you need to notify users that something is happening, and on this screen from SideChart, there's actually a loading indicator, but it's also dark, and you can't see it, but it's on the center of the screen. Facebook instead shows you something that will look like a content you probably would expect to have in the application once the data is loaded. So that means less frustration for the user. And finally, expected state. So SideChart finally downloaded some artworks. You can finally start to browse it. And this is basically the screen that most of us probably start to work on when building a new application. But I would suggest you to start working with blank state, because usually after this we forget that there is a loading state and blank state, and we end up with something like this in SideChart. Second, you always need to remember that your application might be closed and reopened at any time. Given that we're dealing with React Native, and probably most of the time all your state will be stored in the Redux state, which works perfectly if you just open and then close the application, so you will still end up on the same screen. But if you close the application and then force close it, then it will be unloaded from the memory, meaning that next time when the user will open the application, he will need to start everything from scratch. So you need to be prepared for it. And there is like 3 principles that I will suggest for dealing with this case when application might be force closed. First one, you need to use atomic database transactions, you need to persist Redux state, and you need to focus on local data first before displaying some information. Atomic database transactions. I'm really sorry about the image quality, but in short, this is the code. We have a database transaction running, and within this transaction, we're trying to execute SQL. So the first line of code, we're saving a post to database, and within the second line of code, we're assigning this post to the user, so we always know who was the author of this post. Wrapping this into a transaction will mean that if any of these 2 lines of code will fail, the whole transaction will be rejected, and that will ensure that there were no records created for the user without stored post ID, for example. For persisting state, we have Redux Persist. This is a fantastic library. What it allows you to do is it allows you to unload your state, current Redux state, into some kind of local storage. So by default, it will use an async storage for React Native, and it has some configuration, so you can select which reducers you want to unload, which reducers you don't want to unload, and you can configure basically what kind of actions it will do. It will be also either a hard reset or it will be some auto-merging logic. And once you set up this configuration, you can then wrap it into provider or into persist reducer, and then wrap the store with persist store. Next time when you will open your application, you will use this persist gate that will wrap your application, and it will show some loading indicator, meaning notifying the user that the data is currently loading into the memory, and you're done. And the third option is relying on local data. So what does it mean is that, for example, in this component, when it's mounted, you're trying to fetch some data from the server, but if there is some data already existing in memory, for example, in Redux, or in database, it will try to show it first, and then once the new data has come, it will reload the UI. And while developing all this stuff, it's good to follow the three principles. It's optimistic, pessimistic, and pragmatic. And as an optimist, you will try to be optimistic when the user is making some changes. That will mean that you will update the UI as if nothing has wrong. No matter whether you're connected or not, if you're posting a file somewhere or making a post, it will immediately be displayed on the UI. Let me take a pause for a moment because it doesn't make sense without proper setup, because you can't see the code. Okay. Let's try this. No, still doesn't work. And we can try another option. Okay, we probably will need to end up with this, and I will share slides later, so you will be able to read through it another time. So, with optimistic approach, we can use a Redux Optimist library. Basically, what it allows us to do is, for example, you want to fire an action called add to do. So all these examples assumes that you're a bit familiar with Redux. I know that there is Mobix out there, but Redux is still the most popular option for state management. And a part of this add to do action that will just save this text and add it somewhere and probably will dispatch it to the server. We will also create another reducer, which will be called status, that will track the action during its uploading or not uploading time. So we'll have an add to do action, which will notify that there is writing an error, or there is no error, for example. There will be an add to do complete action that will notify the user that data has been successfully uploaded to the server, for example, and add to do failed action that will notify the user that something went wrong. But before this add to do failed action will be fired, the UI for user will be updated as expected. So after we've done all of this, we're importing Redux Optimist into our index reducers and adding it, wrapping the combined reducers function with it. So what Redux Optimist will do for us, it will provide three handy actions like begin, commit, and revert, which will allow you to add this optimist flag to your action, saying that, for example, add to do action will fire a begin, and if there is everything fine, we will then fire a commit action or commit state, and if something has failed, we will fire a revert state. And with our store middleware, we will be able to track what actually we're trying to do if this action has been fired. So with optimistic, we're creating the store, adding this reducer, applying the middleware from the previous screen, and we're done. The second approach is being pessimistic. So all these approaches need to be combined, so you need to be pessimistic and always store changes locally if you can. And for storing local changes, so we will have a function. For example, we've downloaded something from the server, or we're trying to publish a comment. We're storing it locally first, and then we will fire the action that will try to upload it to the server. And you need to be pragmatic. So you need to dispatch action, retry action, and rollback action. By dispatching, I mean that, for example, you're editing some record, you're clicking save, so you dispatch and upload action, for example, and there is an ability to retry this action. We have this a list of items that are pending to upload. There is a reload button or retry button, and you should have an ability to roll back the action. So, for example, if you decided not to publish this comment, or the publishing has been failed on the server, you can roll back the changes and put your comment state into previous state before the action was applied. With all this in mind, we always wonder what can possibly go wrong. We need to remember that offline first is always a compromise. It's a compromise between these 3 points, like this needs to be done yesterday, why it's not done yet. And this is too expensive, I won't pay for it. And why it's not working when I'm on a plane. And to deal with it, you can start with something simple. Like the important bits of something simple is being polite. By being polite, I mean that users should always know where they are and what's happening. And as a developer that always lacks some time, we can find a solution. And if you don't have time, we can just display a notification. It will cost you, like, I don't know, 10 minutes. It's very easy to display. It's very easy to track. And if you don't have time, leave a message. And this message will notify user what's happening. All this needed because of connectivity. Connectivity is a pain point of any mobile application or even web application. But in web, users don't expect it to work without connection. There is a handy tool, it's called Netinfo, it's provided by React Native out of the box. And what it can do, it can determine whether it's connected or not. But the problem with this Netinfo is that it's a Boolean value, while it has some additional details for each platform. So if they're platform specific, it can determine whether it's Wi-Fi connection, edge connection, mobile connection, and so on. It doesn't know whether the connection is good. So it still might, your application with Netinfo still might think that, well, yeah, I'm connected to the internet, but there will be a huge packet lost. Or, for example, there will be a very painfully slow connection, so your user won't be able to ever upload an image to the server. But application will still think that it's connected, everything is fine. That's why we have a React Native offline library. Thank you. So, what it does, it provides a with network connectivity wrapper that you can wrap your whole application with, or any specific component. This wrapper will later be able to pass a property that will be called isConnected, almost the same as for Netinfo. But on top of, so under the hood, it still uses Netinfo, but it extends it with some handy thing. And this extension will allow it to periodically test some server and send a request to it and check whether it's responding. So there is a config file you can pass. The first line is like with Redux. And if you set it to true, it will mean that the property isConnected will be passed to your Redux store, and you will be able to use it across the application. It's handy to wrap the whole application with it if you need to know about the connectivity. You can set a timeout. It will be the time that your component will wait for the ping request. Ping server URL in the docs There is a Google site, suppose, because it probably has the most stable and the highest uptime so far across the other sites, but you can change it. With header request property will actually determine whether there will be an additional ping request for this check for connectivity. And the connection interval is how long you will wait to ping the server at, so how often you will need to ping it. Later you can use the reducer, so you can import this reducer for React Native offline and add it to your combine reducers function, wrap it with network connectivity, pass the property with Redux, and here you go, your application now knows about the connectivity across the whole app. It's stored in your Redux state. On top of that, it provides you some actions. So it provides you with the ability to queue some actions if it's not connected at the moment, almost automatically. So you can pass in additional meta details to your action, which will specify whether you need to retry or not, and whether you should dismiss this action. For dismissing this action, you might specify an array of another actions that will dismiss it. So in this example, for example, we're trying to fetch a post ID. We're trying to fetch a post with ID number 2, and if we're offline, we probably would like to reconnect or retry the action once we will get back online. But if user will navigate back, we don't need to fire this action anymore, because user isn't trying to use this file or to use this post at the moment. And this is a very cool library. We're not using it in our application because we have a little bit more complex solution, but I think next time when I will be developing my own application or some pet project, I will definitely use this one. And another important part of this is the sync order. For example, if you created a comment or created a post and then created a comment that is associated to this post, you need to track precisely what should be uploaded first to the server when the connection will reappear, because if you will try to upload the comment first, it won't be able to assign itself to some feed that currently doesn't exist. And there is always added conflicts. If you're working with something that some other people can work on also, you need to provide like 2 additional parameters. It's like updated at, so your server will be able to determine at what time what change has been made and which should be applied first, and updated by parameter, because you need to know who to blame for these changes. Also, there's performance limitations. Well, when we're talking about React Native, we're always talking about performance, and there is like 4 gaps that you need to be aware of. The first one is fetching data is expensive, so background data fetching, especially if you're doing it in JavaScript thread, it will block the thread, most likely, and you will lose some frames. So your UI will be sluggish. So you need to slice the data and try to do it in some ways that won't interact or won't block your UI. Also, going over the bridge is expensive. By this I mean that if you're trying to use some native library for data storage, like SQLite, and you're trying to pull a huge amount of data out of it into your application, it will mean, or if you're trying to do it too often, it will mean that by passing this data through the bridge and serializing and deserializing this JSON, it might cost you a few frames per second. Rendering big list is expensive, so pagination is a good option. And there's always Android. In general, it's always slower, even with data manipulation on a native level. And now there will be a short bonus. It will be an overview of data persistence and manipulation options for offline. So there's 3 main options that I will consider. It's SQLite, SQL Cipher. SQL Cipher is basically SQLite, but provides you with ability to provide better protection for your data. Apollo Redux. It's not a database, but it's still a good way to store your state and store your data. and Realm. Realm is cool. This is probably the easiest one option, because it's easy to start with. It's offline first by default. It has two-way data syncing, background syncing, it has automatic conflict resolution, has its own database implementation, and a bunch of community and Realm built add-ons. So, like, ideal solution. It also has some drawbacks. The full Realm engine is closed source. That means that you can't hack it easily. It has a restricted data model, so if your data model won't fit with it, or it might be tricky to convert your data model if it's complex to something that Realm will be comfortable to work with. It has background syncing. I don't know why it's cons, because it's a good thing. And it works only with Realm objects, so there's no ability to get raw data. And full platforms, this is the most painful point, it costs money. So as a developer, if you're trying to use like for 10,000 devices, it will cost you around $35 per month. Probably if you're trying to build something more complex than your pet project, it will cost you about $2,000 per year. So you will have access to background data or the server. It's very easy to set up. npm install say Realm, React Native link Realm, and you're done. And you can create an object. Unfortunately, you can't see it, but this is a doc object, doc class. So you're creating a schema, then you're trying to write some data with this schema, and registering your Realm server with some URL, and that's it. It works. Very easy, very expensive. When would I use it? I would like to use it for small business applications that have some money and some budget to run the server and want to save some money on developers' work, on developers' time. For big companies, if they like to develop their server, the Realm server and their own infrastructure, or MVPs, because it's very easy to start, very fast to move on. The second option is Apollo and Redux. So Apollo is basically a GraphQL provider, a good GraphQL provider, and it's an ecosystem with Apollo client, Apollo engine, and Apollo server. The client allows you, it provides you with nice handy functions to get your data and manipulate your data. Apollo engine is a bit more complex. It provides you with some additional extensions like performance tracking, data syncing, memory management, or caching data. And Apollo server is a GraphQL endpoint that will store all your data and will work seamlessly with GraphQL. The downside of it is that there is no automatic background syncing, so you'll need to write your own. According to the previous speaker, it might be very tricky. It's not offline first by default, so you need to find some way to store your data and rehydrate it back if user will reopen the application. There is no automatic conflict resolution compared to Realm, and it's not really a database, but it's fine. Set up a bit more complex. You're installing React Apollo, and then getting Apollo client, and wrapping your component, root component, with Apollo provider. And then you need to install Apollo cache in memory. This will allow you to cache the data from your Realm client. The same thing here, installing it, requiring an image cache, setting up with some HTTP link, and you're good to go. And the most important part here is this Apollo cache persist. It will take the previous one, Apollo cache in memory, and will allow you to upload it or to store it somewhere outside of your React application. By default, it will use an async storage, but you can connect almost anything from the Redux persist library. So it can be SQLite or your favorite option for data storing. And yeah, once you install the storage, cache persist, you need to install a storage. It will be a file system storage, for example, linking it, and your application is good to go. It's offline ready, almost, except there is no syncing. What's cool about it is GraphQL. GraphQL is also cool, and this is probably a topic for another discussion. This solution should work in 90% of the cases, I suppose. It will fit with small businesses, enterprise applications, or any other kind of application, unless you need to provide some high top security or you need to store huge amounts of data or have some complex data scheme. And there goes SQLite and SQL Cipher. This is probably the most painful solution if you're starting from scratch, because this is only a database. So that means that you need to create everything else on top of it. Ideally, you can create a GraphQL layer on top of it that will communicate with your database, effectively fetching data from it. If you don't want to write raw SQL queries, we're not in a PHP world here. And you will need to provide some solution to sync data, to manipulate data, to resolve conflicts. But if you don't have access to the server, or if you have some complex database schema, I think this might work for you. Basically, there's two options. You can install either SQLite storage or SQL Cipher storage. SQL Cipher is basically SQLite, but we've hacked it a bit, so it can work with SQL Cipher. And that's it. You're importing SQLite, opening database, executing SQL inside of transaction, and that's all that you can do. So everything else you will need to write on your own. It will take a lot of time, and it will take a lot of your pain. It probably works like in 1% of cases, but if you know why, I do hope that you will never need to work with SQLite. And if you have a complex database schema, as I told before, good data security, third-party APIs that you can't configure for your GraphQL, cool GraphQL library. And if you have some complex SQL operations, so GraphQL is good, but if you're trying to do some high calculations that you don't want to do in JavaScript, for example, when trying to get some data from the database, then probably you will need to use raw SQL. Questions?
У кого-то есть вопросы?
Hey, thank you for your talk. Actually, I'm a big fan of Apollo client, but I think there is a kind of one issue. Right now, I still use Redux together with new version of Apollo client because I need something like of Redux Saga to describe some kind of flows. So, for instance, in Redux freeway, while I'm persisting data using Apollo and stuff like that, where I should describe my flows.
I'm a big fan of Redux Saga, and I don't think that you can actually opt out of it, especially if you're building something complex. And I can't imagine, I can't answer your questions because I can't imagine the case when you can just use an Apollo without Redux. Redux free world seems unreachable for me at the moment. So.
The same for me, thank you. That's it. I'm trying middleware as well. That doesn't work actually.
Yeah.
Еще вопросы? Точно ни у кого нет?
Okay. Thank you.